Okay, so before I start, it's not so late as well. Now, before I start, there's a couple of small problems from the last exercise. What number is that? 2. So can you have a look at 2G? 2G. 38. Now there might, and which one, Naveed, which one was the problem for you? Okay, well let's just deal with 2G first. So if you have a look at 2G, please. Alright, 2G. 38.
Page 36?
38, 2G. Okay. So we have. What's wrong? No, just be quiet and look up at this now. 5x plus 2y equals 0. Okay. Minus 5x squared plus 8xy plus 4y squared equals 0. So this first one here, I can rewrite it as y equals minus 5 over 2x. So, Donna, did you do that first?
Yeah.
Yeah, okay. So now I put that in here. And I get minus 5x squared and then 8xy. So this gets multiplied by 8 and x. So plus 8xy minus 5 over 2x plus 4y squared needs to equal 0. So now I have minus 5x squared minus 20x plus 25x squared equals 0. Sorry, what's wrong? Minus 20x squared. Oh yeah, squared here, thank you. 0. 0 equals 0. Yeah. So this is the problem that you had. Which is fine, it means that there isn't an answer here. So there is one there. But wait. There isn't wait. Just listen. Okay? This has not given us an answer. But that does not mean that there actually is no answer. Now forget about the answer at the back. Okay? Look at these two equations. You can actually see what the answer is by looking at them.
What was the answer?
0, 0. But can you look at the equation and see why 0, 0 is an answer?
Why? Because 5x plus 2y everything squared
Is it derived from 5x?
Because 5x.
No, no.
It's the same thing, but one's positive, one negative.
No, just look at the equation. Everything has an x and a y in it, doesn't it?
Yeah.
And both equations need to equal 0, don't they? So one answer would be if x and y are both 0. Then they are both equal to 0. So we can see that 0, 0 is an answer. But this has not given us an answer. So the question is then, what is the problem here? Why has this not worked? Well, it might be helpful to look at the graph. I don't know. So before going ahead, I think it'd be nice if we have a look at what the graph looks like, okay? And then we'll talk more about it. So opening up the graph here. Okay. No, la is only when it looks bad. This won't look bad.
What if you for y instead of x?
We could try that. I have a feeling that it'll probably be the same thing, yeah?
Minus 4y squared plus 4y squared.
How do you graph it?
Okay, so 5x plus 2y equals 0. And then minus 5x squared plus 8xy plus 4y squared. Okay, so the first one, I'll graph it there. It's a straight line. Second one, you haven't seen this graph yet. Don't worry too much about it, but it might look a bit strange. Too many. Oh, sorry, forgot equals 0. Thank you. Yeah. Okay, so what has happened is that you can't actually see the graph anymore, but the two graphs are actually lined up. Maybe if I undo one of them, let me clear this. Let me just draw this one first. So that graph looks like that. Okay, but then when I draw the other graph, 5x plus 2y equals 0, watch what happens when I graph this one. Not quite exactly the same, but you see it lines up on part of the graph. So that's why we have it. It's not saying that there's no answer. What you'll notice is it's saying that like any value would be an answer. And that's because this graph meets not once, not twice, but many, many times because they're lined up. Okay? Yeah. Like for example, let's just take this here. Oops. You know what I'm doing, a box. Okay. Now, if x equals 0, what does y equal? 0. If I put that into both equations, do they both equal 0? Yeah. Now, if I put x equals 1, what should y equal? Well, let me choose a nice number. If I put x equals 10, what will y equal? It'd be 10 here, minus 25. Now, I would like people to check that. Let's put 10 and 25 into the first one. So I have 5 times 10 plus 2 times minus 25. What's that equal to? 0. Now, let's put that into the second one. Minus 5, 10 squared plus 8, 10 times minus 25. Can you tell me, calculate it please on the calculator. So this here, 2 times 3, 625 times 4. And then this one here would be 4, 8, 2000, is it? And then this is minus 500. I don't know. I don't have a calculator. So what does this equal?
This equals 0.
It's equal to 0. See what's happening? Now, as long as we choose any value of x or y that satisfies this equation, the other one is automatically true. So there's actually many, many answers. So I have 2 answers at the back. There's actually wrong. There's infinite answers. 0, 0 is only one answer. There are many answers. But you're right, 0, 0 is an answer. Now, yes?
Are we going to get this type of question in the exam as well?
No,
By
no.
many, you mean infinite?
Infinite many. Yeah, infinitely many. I want to draw you back to something we did a while ago. You know when we have our elimination, like this one here. And this equation here. You see that? If I try to solve these, I won't get an answer. Because if I multiply this first one by 2, what would happen? They're both the same. So I don't really have 2 equations. How many do I have there? It's really only 1. They're 2 lines, but they're actually the same line on top of each other. So it's actually the same line. So that must mean for 2g that the second equation is somehow really the first equation. I would like people just to spend a minute or 2 on this. What? No. 2 minutes. I would like people to see if they can change the first equation into the second equation. Example. How do I change this one into this one?
Times 2.
Times 2. I'll give you a minute. See if it's possible to change the first one into the second one. 2g. Yes.
No.
Yeah. You're allowed to multiply, yeah. As long as it's not 0. Huh? Oh yeah, you could do that one, yeah. Yeah. You think you have it? Good job. Okay, so let's take this equation. 5x plus 2y equals 0. Yeah, what did you say?
Minus x plus 2y.
Yeah, you said multiply this by minus x plus y. Should that still equal... Is that what you said? 2y. If this is true... Wait, hold on. Just listen. If this is true, and I multiply both sides by minus 2x plus y, is it still true? What do you think? Yes, it is. All right? If I take a number that's equal to 0, and I multiply it by another number, is it still equal to 0?
Yeah.
Yeah, because no matter what, you will always get 0 here. So what Ire suggested was we multiply both sides by this number. Now, if I multiply here, I get minus 5x squared plus 10xy minus 2xy minus 4y squared. That's equal to 0. So here I get minus 5x squared minus 8xy minus 4y squared. That's equal to 0.
Plus 2xy.
Oh, sorry, plus here. Sorry.
Plus 8x.
Yeah.
Plus 8xy as well.
8xy?
Yeah, plus.
Oh, sorry, plus, sorry. Yeah. Now, just please note what you did here. This equation is true. And we accept that if this is true, then so is this. This is also true. And so is this, and so is this. In other words, if this is true, then this one is automatically true. So no matter what values of x and y we choose, if we choose values that make this true, then this one here is automatically true. So there actually isn't really two conditions here. There's only one condition. That's why there's infinite answers. That's why you had trouble with this. Okay? So that is a good one. It's difficult. You won't get that in the exam. But it really makes sure that it tests your understanding. Okay, so that was a good question.
No, I'm sorry, what do you mean by true? Sorry.
What do I mean by true?
That is like it equal to 0, that's it.
Yeah, as in it is equal to 0, that it is true, yeah. Instead of not equal to 0.
This is required in the exam.
What?
This is required to be done in the exam.
No.
You just say it. Sorry, I just do it. Because it's too
Yeah,
complicated.
don't drift away. Yeah, don't. All right, we'll go to the next topic now. Okay, so page 40.
So what's the difference between solve the following systems and the one above it? Just the first one was just sketching.
Sketch and solve. Solve. Yeah. Okay.
Oh no.
Yeah, inequalities.
Oh my god, inequalities. I hate those.
Yeah.
Guys, I'm waiting.
Those are the ones in the on this 18.
I'm waiting. I'm going to start when you are ready.
You ready?
Now, what we're going to look at here is inequality. So this is actually the last worksheet on chapter 2. Okay. So before we start, just a little bit of some definitions. So firstly, this here means all real numbers. In other words, any number for us right now, all real numbers. This one here, these are just the positive and negative whole numbers. Sorry. Including 0.
All real numbers include 0 as well?
Yes. Yeah. This one here is all the fractions, P over Q, where P is any whole number and Q is any whole number, and Q, of course, cannot be 0.
So fractions.
For fractions, basically. So we have all real numbers, positive and negative whole numbers, which are called integers, by the way. Q, which is the fractions, which are called rational numbers. And then the last one here, the natural numbers. What are the natural numbers?
Those who can
Are
be
you doing
divided
everything
by
but
1
0?
or by itself.
No, that's the prime numbers.
Everything but 0?
Yeah, no, it's all the positive whole numbers, but do we include 0 or not?
No,
Zero's not positive.
because 0 is not natural.
But the problem is, some people in their maths book include it and some don't. Okay, so I was just curious to, if you've seen this in high school, do you include it or not?
No.
Maybe some do, some don't. But I'm saying that you might open one maths book, they include 0, another maths book would not include 0. So the way to prevent confusion is as follows. If I want to include 0, I'll write a little 0 here. And then if I don't want to include 0, I'll put a little star.
So this is what they do.
So this is, this is universally true in every maths book. Okay? But what's not universally true is in some maths books they'll say n equals n0, but some maths books will say n equals n star. So some books include 0, some don't. So I will try not to use n. I will try to put a 0 or a star to show you if I want 0 or not. Okay. Right. And then just a bit more notation as well before I start. Can I scroll down? Yep. Okay. Yes. Now, just to be clear, well, I won't use or. What does this do when you have two sets? No. Combines them, doesn't it? So this one combines. And then what does this one do? The intersection. So this one puts the two sets together and takes everything. And then this one here is just what's in common. So for example, 1, 2, 3 union 2, 3, 4. What would that be? 1, 2, 3, 4. And then if I had intersection instead, it'd just be 2 and 3. Because they're the only ones that are in common. This symbol here, A exclude B. What this means is you have A and you remove from A what is in B. So for example here, 1, 2, 3 exclude 2, 3, 4. So what this means is cancel out 2, 3, 4 from the first one. So you're just left with 1 then. Yeah? What's in A? No. No. What's in A? 1, 2, 3. And what's in B? 2, 3, 4. So it means start with A and exclude from it that which is also in B. So also in B is 2, 3. So they get excluded from A.
So,
It's like a subtraction
What
almost.
about the
so the diagram would be for the exclusion.
Yeah, what would be the diagram?
Yeah.
So this is the diagram. Here is A, here is B, and then what you do is you have A,
Actually,
but then you remove what it shares with B. So actually that's it just there.
But what about 4?
B prime, but that would also include what's outside of A, if there was something outside the 2 here. So it's not. It's almost B prime, and it would be B prime if there was nothing outside A and B.
What about 4?
Yeah, 4 is not in the first one, so it has no effect.
So we will not be shaded.
No.
what about the sandwiches?
Sandwiches?
Here of sandwiches.
That belongs, yeah. Yeah. So, no, I don't want to spend too much time on this because every middle school student does this. So I'm just trying to refresh memory here. Like this is like middle school year 1, isn't it? Year 2 maybe? You've done this in middle school.
Maybe.
What's that?
Too young.
Venn diagrams, yeah. Also, this means belong. So this means 2 is inside A, which it is. 2 is inside A. Sorry, this is just a refresher. This isn't me showing you something new. What I'm going to do next is something which will be new for some people, okay? No, even before that.
The stuff in the SAT.
You be quiet now. Okay. If I write this means all the numbers which are real and which are between A and B, including A and B. So in other words, it's all the numbers in between A and B, including A and B. That's what this means. So on a number line, it's basically saying there's A, there's B, and it's all of these numbers.
Can you just write X includes and break?
X includes.
So X includes and then left break A. That's how we do it.
Oh, like this?
Yeah.
Yeah. Yeah, just saying X is in AB. Yeah. Okay. This has a name. This is called a closed set. And an open set is this one. And it's the same idea, except for we don't include the A and the B. So it's all the numbers between A and B except A and B. So do not include A and B. So again, it would look like the same thing, except A and B are not included. That's the only difference. This is called an open set. Can you mix open and closed? You can. So for example, if you had something like this,
Just A.
yeah,
That's
it's
like B.
yeah, that's it, yeah. All the numbers between A and B, but we have the A and we don't have the B. So, what's this?
From minus infinity to
Yeah.
It's like all
It's all real numbers. So actually, that's another way of saying all real numbers. All the numbers from minus infinity to infinity. Okay? Note, infinity not included. Infinity is not a real number. I'll say that again because someone will ask me later. Infinity is not a real number. So when we get an equation with only one answer that's something weird like infinity, and then someone says, "Oh, teacher, isn't infinity an answer?" I'll say, no, infinity is not a real number. Okay? What? Look, you see, just be quiet. Right. Okay, so now we'll have a look at some inequalities. So in question 1, it's just sort of basic ones to get us started. Can I scroll down now? Yeah. Yes?
Yes.
Yes, okay. So, as an example, well, even actually, you know what, before I start, I'll just say it. For this one, and this one, they all have the same algebra rules except for one, which is the following. If I have something like a less than b, and I multiply or divide both sides by a negative number, making it minus a and minus b as an example, the only exception is, or sorry, not the only exception, the only extra rule is that the sign gets flipped around. And the reason for that is, if you think about it, 5 is less than 6, that's true. Minus 5 is not less than minus 6. That doesn't make sense, because minus 6 is actually smaller than minus 5. It's further to the left on the number line.
Like if we change like positive to negative,
We have to flip it. Okay. But I'm sure a lot of people know that already. I just wanted to say it. We obey the same rules with one extra. Negative multiplication or division flips it around. Okay? That's the only exception. Not exception, sorry, the only addition. Right, so let's have a look at some examples now. So I'll do 1a. We're told that x is a real number, and we want to solve this. Minus 5x less than or equal to x plus 6. So just like normal, that comes over there. And we have this. And then we divide by minus 6. We have to remember to flip it around. So we have minus 1. Now, you can leave your answer like this, but there are other ways to present your answer which they might want in the exam. So we could say this is our answer, or we could say x is from minus 1 to infinity. Now, Hussein, x is bigger than minus 1, right? That's the same as this. X is all the numbers from minus 1 to infinity. It's bigger than minus 1. If you look at it on the number line, here's the number line. There's 0, there's minus 1, there's 1. What are my solutions? If you look here, it's all the numbers bigger than minus 1. So that's all these numbers from minus 1 to infinity. If I want to show that minus 1 is included, I colour it in, and this would be not minus 1. So this one minus 1 is included, and then this one will be not minus 1. So I'm saying minus 1 to infinity.
So only when we're dividing any number that's negative.
It flips it.
So, how did you know that it's open from the above afterwards minus 1?
What do you mean?
Like you said, this can be open and closed, yeah? Like open set and...
Well, I know it's closed because I know it can equal minus 1 because of this.
Oh,
And infinity is never included.
yeah.
So that's why.
Is it okay like if we put minus x bigger than...
Yeah, well, you could have minus x is smaller than 1. But then you have to multiply both sides by minus 1 because you don't want minus x, you want x. So then as soon as you do that, you get the same thing. So it will be the same. I would like everybody to do B for me just to make sure you've got it. So do B for me. One B. Okay, do we have the answer?
7?
X must be bigger than 7. So X is all the numbers bigger than and including 7. So on the number line it would look like this. There's 7 and it's all the numbers from 7 onwards. So these are just linear inequalities. So we'll go on to the next one now. No, still more linear. 2. Oh, sorry, that was 2. Sorry. Now 3a.
When we write the answer,
Yep.
do you have to write it in the same format as
I'm just showing you this format because they might ask for that in the exam. So I'm just showing you both ways to write the answer, like this or like this, and then here it is as a graph as well.
The X includes 7, that's set notation from number 2. The S give your answer in set.
Does it say, oh, well, then you have to give it, yeah, that's set notation, yeah. Yeah. Sorry, I didn't realize I asked for that. Yes, you need to give it as a set. Yeah.
I have to do C now.
No, I'm going to do C now. But, sorry, no, not C. I'm going on to 3 now, different type. Okay. Sorry, that was 2. Now 3. So this type.
No, they didn't.
No, sorry, I didn't realize
I tried for the second.
I was doing number 2. There's a sneaky number 1 up the top.
Yeah.
Yes. Now, these aren't too different. In fact, the only difference here is that there are 2 inequalities. And in fact, you could break this into 2 problems if you wanted to. So you could, if you wish, do this problem first and then do this one second. So you could look at this first, solve that, and then go for this one second and solve that. But that's not the best way to do it. I mean, that's not the quickest way to do it. So I'll show you the quickest way to do it. So what we do first is we minus 5 from everything. Minus 5 here, and then minus 5 in the middle one, and then minus 5 in the last one. And the reason for that is so it cancelled the 5 in the middle. So we got minus 16 less than or equal to minus 4x less than or equal to, what's that, 8, isn't it? So what you're doing is you're removing 5 from all 3. Because you don't want this 5 here. Yeah, no. Are you writing this down? I'll ask you again. Did you write this down?
No, sir. I wouldn't know.
That's better. Now, what do I do next? I want to get rid of the minus 4. So, I should divide everything by minus 4. Minus 4, minus 4, minus 4. But don't forget,
change this?
flip them around. So this one here would be 4, but it's flipped, x, and it's flipped, and here, minus 2. So x is between minus 2 and 4. It looks a bit weird because it's written backwards there, so I'll just write it the other way. X is between minus 2 and 4, which means x belongs to minus 2 to 4. But I'm not actually finished, because in the question, what do I tell you about x as well? It is a natural number not including 0. So if I draw my number line, now just wait, here's minus 2, minus 1, 0, 1, 2, 3, 4. I tell you that x is only these numbers, not 0. And the solution is minus 2 to 4. So that's all of these numbers.
3, 2, and minus 1, minus
Yeah, so actually the answers are really only 1, 2, 3, and 4.
But what about minus 1?
No, because that's not
A natural number.
your natural number. and I tell you in the question x must be natural. So this condition and this condition together means that x can only be 1, 2, 3, and 4. That's the actual answer. 1 second. Yeah? Yeah, I shaded in -2 to 4 because that was the solution. And I put dots on 1, 2, 3, 4 because we're told x can only be natural numbers. And I just see where they overlap. So they only overlap here, 1, 2, 3, 4. Like x could be 5, but 5 is no good because it's not here.
So, when I draw the lines, I do from 1 to 4 and that's it.
For what?
I just exclude 0, -1, -2.
Yeah, okay, that's fine. I want everybody to do B for me now. 3B. Do 3B. Okay. If you're working on it still, that's okay. I'm going to do it up on the board now. So, it will be this.
Yep, I got it.
So. Huh? Oh, yes, thank you. Oh. Yeah, wrong way around. Okay, so that means because we're told that x must be a whole number as well, an integer. So that means x can only be -11, -10, etc., all the way to -3. Yep. What's wrong? Yes. Okay, you have that one taken down? Yeah. So now that's linear, a few examples of linear. So let's look at a quadratic. Now there's two ways to do quadratic. Yeah, two ways. I'll show you both ways and you can do whichever way you prefer in the exam. Okay. So this is actually like 4a now. 21x squared plus 32x plus 12 greater than or equal to 0. So, oh, and x is a real number. First, I'll try to factorize it. So what have I got here? 7 and 3 probably. That'd make 21 and 12 and 1?
So what number is this?
No, the other way around maybe.
B?
No. 4 and 3 make 28. Which way is 4 and the 3?
Plus 2.
2 and 6, not 4 and 3. And what goes here? 6. Okay, thank you. And they'll both be plus. Okay. So what we've done is we factorize a quadratic. Now this isn't the way I like to do it. I prefer to do it using the quadratic formula and a graph. But before I do that, I'll show you this way because, I don't know, some people like this way. Okay, we want this to be positive. So if I want this to be positive, what do I know about these two pieces, these two factors?
They are equal. More.
Yeah, they're both positive.
Yeah.
Is that all? Both negative. So you have two possibilities to consider. The first one is a positive and a positive, or a negative and a negative. So what I'm doing here is I'm changing this into two linear problems. 7x plus 6 is to be positive, and 3x plus 2 is to be positive. So this means x must be greater than or equal to minus 6 over 7, and x must be greater than or equal to minus 2 over 3. Now, this and here is very important because we need both of these to be true at the same time. So we need this and this. Let's have a look at a number line. So this one is further to the left, minus 6 over 7. Yeah, and then here will be like minus 2 over 3. Okay, so I need x to be bigger than minus 6 over 7. That's all these numbers. And I need x to be bigger than minus 2 over 3. There's only one way both of them can be true. And the only way both of them can be true is if x is bigger than or equal minus 2 over 3. So that's my first answer. Now I'll do the second possibility. We need 7x plus 6 to be smaller than 0 and 3x plus 2 to be smaller than 0. So that means x must be smaller than minus 6 over 7 and x must be smaller than minus 2 over 3. So my number line again, there is minus 6 over 7 and there is minus 2 over 3. I need x to be smaller than minus 6 over 7 and to be smaller than minus 2 over 3. Yeah, the only way that can be true is if x is smaller than or equal to minus 6 over 7. It's the only way both can be true at the same time. So this means our answer is here. But I want to write this in set notation now. So if I draw a big number line here for this, here is minus 6 over 7, and here is minus 2 over 3. So I want x to be bigger than this number, or smaller than this number. So that means I want x to be somewhere between minus infinity and minus 6 over 7, or minus 2 over 3 to infinity.
Yeah.
Yeah. In other words, don't use x between minus 6 over 7 and minus 2 over 3. Now, there's a lot there. I'll give you a minute to write it down. Yeah.
They should be in the square brackets.
Oh, sorry, you're right, because I'm allowed to include those here. So this is actually a square bracket. Because they're equals here. Thank you. Okay, I'll let you write that down. That's, yeah. Can you see that? Oh, no, you can't. Can you see that okay? No, do you need me to zoom out?
Yes.
Yeah. The reason for the square brackets was because you see the way in the inequality I have greater than or equal because of the two lines. I can't quite see it there. So that means we can include minus 2 over 3 and we can include minus 6 over 7. So square brackets just mean I can include this number. That's all they mean. And a round bracket means don't include this number. So include square brackets. Yeah? Yes, yeah. The graph, which is much quicker. Oh, you should do the method I'm going to show you next. Yes, which I'm sure will be your method also. With the graph. Yeah, well look, the only reason I did this is because when I show people just one method and I tell them there's another method, they say, well, we want to see the other method because they think it's better. Because I'm not showing them, like I'm holding it secret or something. So I'm showing you both. So you can't accuse me of not showing you a method. If it was up to me, I would just show you the second method, which is what I'm going to do now. Okay, the second method. Okay, can I scroll down now? I'll be quick. Okay, scrolling down. So what I'm going to do is I'm going to do 4b, but using a different method. Okay? (4b). Minus 7x squared minus 41x minus 63 less than or equal to minus x squared. Okay, I know that that looks like a different type of problem, but if I just rearrange it slightly, it becomes the same. If I take the minus x squared to the left, I get minus 8x squared minus 41x minus 63. No. Tal, be quiet. You're annoying me now. I got my mistake, yes. Well, that... Bad, Stephen. There, 6. What? Did you just say agreed?
What did I miss?
You'll pay for that. Okay. So now, second method here. I've changed it so it looks more like the problem I did a moment ago. Okay. The second method, what I do is I say y equals this, and I think of it as a quadratic. And I can just use my quadratic formula. So A, B, and C, I get two answers. What are my two answers here? Yeah, but just you can put it on the calculator as a formula. Give us that calculator there. No, that one. I want that exact one. Right.
It's the same though. Minus
That's
27
his
over
favorite
7.
calculator.
No, but it's the same.
No.
This one's silver. That makes it cooler.
Yeah, it is different than the color.
Yes. So find minus 7 over 3 or minus 9 over 2. So what we do is we imagine we draw this quadratic and we have the two roots. So if I do a quick sketch here, this is about minus 4.5 and this is, yeah.
So why is there a 6 instead of a 7?
Here I took the minus x squared to the left. What?
Oh, okay.
Yeah. Minus 4.5 and minus 2.3. So the minus 9 over 2 is further out. And then here's minus 7 over 3. Okay, so there are the two roots. Now, what shape is this quadratic? Is it a U shape or a hill shape? No, hill shape. Because of the minus. So it goes like this. Okay. Now this is the y-axis. Yes, of course it is. If I go back here, this is equal to y, and I want this to be negative. So I want y to be smaller than or equal to 0. So if I look at my graph, that's everything here. Under. I want y to be negative. Here is positive y and here is negative y.
Why do you want it to be?
How did you get a y?
Hang on, hold on. Hang on. Dudes, chill. Yeah.
I think I have another explanation of the signs and stuff. It
Here?
might be a bit easier. Without
Flip
the
it.
Without the y-axis, just if you have the minus coefficient with x squared, then signs will go minus plus minus. If it's positive, then plus minus plus.
That's fine, and some people
And
do it
then-
like that.
And you see the sign, and if it's
That's fine, and some people do it like that, but I much prefer having the graph on the page as well. It prevents confusion. At least I hope so. It seems like there's some confusion here.
Just without y-axis, just the next line.
Okay, what else can I say? Alright, look. This here is equal to y, and you see here, this is less than 0. What does less than 0 mean? It means negative. Negative. So this is positive y, and then down here, negative y.
Yeah.
So where is the graph negative? Here
And here.
and here. So what values of x get me in that part of the graph? Values of x that are smaller than minus 9 over 2 or bigger than minus 7 over 3. So that's the answer. X needs to be smaller than minus 9 over 2 or bigger than minus 7 over 3.
So,
Yeah.
just a question. How did you get minus 7 over 3 or minus 9 over 2?
Quadratic formula on the
So
calculator.
I could do it.
The minus b formula.
y factor.
Minus, oh, it's,
Just the formula. Yeah.
oh, okay.
Yeah. No.
I could do
You give me a question, not a statement. Shh. Be quiet. Just for a moment. I can't hear the question. How did I get the last statement? Sure. Would you like another example or just to see this one again? I'll do another example. Or do you want... Well, I'll do both.
We have to
So-
sketch it.
For this method, yes. 1 second. I'm going to explain how I got the last line. Then I'm going to do another example. Then we can see if there's more questions. Yes. Okay. So, just remove the last line here. How far back do you need me to go? Back further? Just the last line. Okay. So if we look here, I want y to be negative. Y is positive here and here, but negative down below. I want negative, which means I want my x to be here, because this part of the curve is negative. And I want my x to be, or I want my x to be here, because this part of the curve is negative. So I want x to be smaller than minus 9 over 2, or x can be bigger than minus 7 over 3. That's the answer. But sometimes they want the answer as a set. This is all the numbers from minus infinity to minus 9 over 2. Minus infinity to minus 9 over 2. And then this is all the numbers from minus 7 over 3 to infinity. All the numbers from minus 7 over 3 to infinity. So either of those will do. So you can give your answer like this, or give it like this. They mean the same thing. Fall asleep again. Consequences will be dire. It's like resting your eyes. Yeah. So tired of looking at maths. I just need to close my eyes for a minute.
Until you finish re-explaining the point.
All right, you're just recharging, is it? Yeah. Yeah. You need one turn to recharge, and then the next turn you can do the studying. Is it? It's like this. You know what I'm talking about, right? Yeah. Do you need another example of this, or not? No. Well, I tell you what. We have the tutorial class on Monday if you need to see more. Okay. Now, you'll notice that I actually haven't done anything from number 5. Number 5 is the same as number 4. The way you deal with number 5 is you split it into 2 number 4 problems. So if you look at number 5, that's actually 2 problems. You first do the quadratic more than 71, then you do the quadratic less than 97. Yeah, no, I'll give it to you as a homework, but I'll just give you one of them to do, just see how you get on. Okay? No. I will see how you do by yourself. Let's independent learners, blah, blah, blah. And then, if there is a problem, I'll do it, which there will be, so I will end up doing it in the next class anyways. Okay? Well, now, the ones I'd like you to do, so from number 1, you can make it highlighter. Close enough. Okay, so from number 1, I'd like you to do x, y, and z.
From number 2.
Sorry, yeah, from number 2, x, y, and z. From number 3, I would like t, u, and v. T, u, and v. Then from number 4, I would like, I want to do, hang on, no, just be quiet. B, I didn't do B, no, I did do B, sorry. No, not B. E and F. E and F. And then from number 5, you can do A. Okay. Wait. Do that sound again. Physics students know what I'm talking about. No. Right, I'll tell you what we'll do. Yeah, we can. You know what I'll do? I'll do something like, I'll take your friend here and I'll tie him on top of one of the poles or something. I'll just throw it. Okay? Right, and then I know you won't be able to sleep at night without him. Okay?
It's like I got another one.
Okay, so what we'll do is, if you can just do those for until 3:15. Okay? The next class is very short, and we'll just finish a little early. Okay? Because I know from looking at you, you all kind of look a bit brain dead. So, just do this for 6 minutes or so. We'll do the next class, it's quite short, and then we'll finish a little early, okay? Oh yeah, if it's bigger than 0, then you want the positive y, so whatever is part that is above instead of below. It's just the other side.